All right, as you guys know, today's agenda would be to cover a few bits regarding, like in a broad terminology, regarding implementation of authentication control, right? Implementation of your identity and account management controls, and implementing a secure mobile solution as well. So, like, it's pretty much of a very much in deep regarding your certification and whole modules if we talk about in a security plus. But we'll try to cover most of the bit over here, right? So that you guys can have a better understanding regarding these terminologies, so that whenever you go out, right, and out in the world regarding the cybersecurity field, you'll be aware of these terminologies over there. Okay, so this will help you out to stand out from various people. Okay, so it's not like of a topic for which you guys need a hardcore cybersecurity background or something like that. Okay, these are the general terms. I believe I will try to make it clear as simple as possible, and you guys will be able to grab it. Okay, so guys, as you can see, the very first topic is implementing authentication control. So here we will be discussing regarding authentication, okay, and all those designs, factors, controls, and various bit over here. Okay, so first of all, what do you understand by the term authentication? Perfect. So it's a method of validating, right, a particular entity's or individual's unique credentials, you can say. We talk more about into this core ones, right? So authentication is the way of proving that the user is same as it claims to be, right, when it attempts to access the resources, right? So what it does, it checks like, does an individual have the correct credentials to access the system or not, doesn't it? It keeps credentials secret to prevent any unauthorized access to your confidential information over here. So in short, like authentication, it requires the account holder to submit credential that should only be known or held by them in order to access the account, doesn't it? Right? So there are many authentication technologies, guys, that are important and you should know about those security controls. Okay, so we'll jump into more security controls. Okay, so before that, what are we trying to go over here is like, we'll go with the authentication factors over here now. Okay, so authentication factors, if we talk about authentication factors, guys, so first of all, let's suppose an account has been created securely. Okay, and identity of the account holder has been verified. All right, now your authentication, what it does, it verifies that only the account holder is able to use the account, isn't it? And that system will be used by account holders only, right? So authentication is performed when the account holder supplies the correct credentials to the system. These are compared to the credentials stored on the system over there, right? So if they match, the account is authenticated, isn't it? So let's say if you are inputting a password, a username and password, right? Taking an example of a database, right? You can consider databases over there. Okay, so consider an example of a database, right? So for example, if you are taking a normal username input and a password as an input, okay, so we have these two input fields as in, guys, place where you give the input, right? So you might have seen while logging in and every place, after your username, let's say here's a username written and here's the password is written also, isn't it? So after this username and password, these fields are mentioned where you give your input. So that's why it's known as your input field over here. So in username, let's say whatever the username is there, you give the XYZ and you put up a password over here, right? So what happens, these credentials are checked into the background area, right? Somewhere, obviously, right, while you are registering, okay, or there might be any sort of a database or any place where all these credentials are being stored in the system, isn't it? That's pretty obvious. So let's say, considering an example of a database over here, okay, something like this. So let's say there's a database behind it, all right, and now you input a username over here and you give the password. Okay, so all these things will be carried out, okay, and it will be passing to your database over here. It will be checking, okay, where does this username belongs to. Let's say this username belongs to the very first row, okay, The rows are in this way, guys. Okay, and the columns are in this way. Cool. So he'll be checking. Okay, username is falling into this first row, and whatever the column is, let's say for the first column. Now he'll be checking for the password. Okay, so let's say you put up a password as pass only. So it will be checking this column, this column, this column, the entire columns which are in this particular table. Okay, your database consists of many more tables over there. So let's say this is one of the table, and name is ABC for now. So what is happening now? You entered a username and a password. It went to your database, right? There is a query will be running over there. So everything you can say like a command. These are like querying when you call it in terms of database. Okay. So queries will be running out. It will be checking, okay, XYZ username is there. He falls in your row 1, column 1. Then he'll be checking for the password now. Now, checking for the password, he'll be checking like on the password column, okay. There will be name of these columns. Let's say the first column having the name username. For second column, it's password. It's be like email ID, mobile number, and so on. Okay, so it will be checking on the username. Username, okay, check XYZ is over here. Perfect. Now it will be checking on the column which has the password. So let's say the very second column is regarding your passwords. So it will be checking this password because it's being traveled to your database now with the queries. It will be checking whether this password belongs to this username or not, right? So it will be checking whether this password belongs to this username or not. So it will be checking over here, and when it confirms it, okay, this password belongs to XYZ, it will be giving you the access, right? And if not, it won't give you the access. So basically, you guys, to be telling more about database, the database talks in the terms of true and false, you can say. Okay, so if your query, if this condition is true, it will be replying you with the true, and you will be getting the access to the further page. And if it's false, it won't allow you to get inside it. Okay, for that matter, like in talking about any system or in talking about an organization, everything is maintained on the back of the back end, right? So it will be just cross-checking all those credentials which are stored over here, and it will be cross-checking with that. And if it matches, it will allow you the access. Else, it won't allow you the access over there. Clear with this thing? Perfect. So now, since we are talking about the authentication factors, right? So as you can see, there are many different technologies for defining credentials, and they are categorized as factors over here. So you can see something you know, right? What do you understand by something you know, guys? So first of all, guys, as you have mentioned the one thing, which something you memorize, right? What you memorize or something like that, isn't it? So can we put it up as calling it as a knowledge factor, isn't it? It's like a knowledge factor over here, right? Something you are memorizing, isn't it? Perfect. So when we talk about login, we enter username and password. The username is typically not a secret, isn't it? It's typically not a secret, but the password must only be known to the account holder. Am I right? Perfect. So following things are in your something you know, right? As your password, a PIN, your swipe pattern, your challenge quotient, password resets, and all these things, isn't it? So that's a perfect one. You already know, like what's something you know, right? So it's more of like a knowledge factor over here. Then it brings to our something you have. So what do you understand by the something you have? So guys, first of all, if we are talking about something you have, right? It's your ownership factor, isn't it? Right? It's your ownership factor. Means that the account holder possesses something that no one else does, isn't it? Like your smart card or a USB 4 that generate a unique code. You guys know what is a USB 4? So it's just like a USB. It like creates an unique code for you through which you can just sign into the system also. Okay, it generates a code over there. Perfect. So USB 4 that generates a unique code over here. So these ownership factors can be described as hard tokens, right? I have seen like if you have mentioned the soft tokens as well and the hard tokens, that's pretty nice. Perfect. So a device such as your smartphone, guys, can also be used to receive a uniquely generated access code, right, as a soft token, isn't it? So unlike a password, these tokens are valid for only one use. Typically within a, let's say, you also see there's a time window mentioned with that. Like, let's say like one minute is allowed or 5 minutes are allowed. So if you are using these things, these soft tokens within 5 minutes, then you are authorized, else it expires and it won't allow you to log in. Am I right? Perfect. So that's your something you have. Then we have another one factor, which is your something you are or something you do. So as you can see, fingerprints and handprints are mentioned. So basically your authentication are divided into these factors, guys, right? Something you have, something you know, and something you are, right? So something you are is your which factor? Biometric factor. Exactly. So, like what you do, you uses either physiological identifiers such as your fingerprint or handprints, right? So when the user authenticates, another scan is taken and compared to the template, isn't it? So what you do, let's say whenever you're trying to scan or when you put up a fingerprint or any sort of a scan or this biometric factor, right? Handprints, fingerprints. So what they do, they make a template out of it, isn't it? They record your for the first time whenever a user is trying to give a scan. Okay, so they make a template out of it. Okay, so they will store that template with themselves. The system will be storing, you can say, that template in a database or any secure place. Okay, now what happens whenever you are trying to, let's say, enter in an organization or trying to use any system or whatever thing you are trying to go for, and it uses a biometric factor. So you put up a thumb, right, or you put up a finger, it gets scanned, and when it gets scanned, it is compared to the template which is being stored in the backend, right? So if those templates matches, you get the access, else you won't. All right, I hope that's clear to everyone. So which brings us to our next one, which is your, we'll also get with the attributes. Before that, it's your authentication designs, right? So what do you understand by the authentication design? But basically when we trying to talk about authentication design, it's mentioned, right, it meets the requirements of confidentiality, integrity, and availability, right? So see, if we talk about confidentiality, it means like keeping the credentials secure, isn't it? And if we talk in terms of integrity, integrity means yeah, 45 CI triad is completed. Perfect. Yeah, guys. So if we talk about integrity, threat actors, they cannot bypass the authentication mechanism, isn't it? Because if they are able to bypass it, that's like a, like breaking the integrity over there, isn't it? And if you talk about the availability over here, so in availability, the mechanism, you can say, that does not cause any undue delay or any sort of a support issues in the work. So any sort of a method or a mechanism which is causing any trouble to the work environment, you can put it up into your availability. So basically, your authentication design should be so perfect, so well maintained, you can say, so that it can meet the requirements of confidentiality, integrity, and your availability, right? See, actually, authentication, right, is used in like different contexts and factors, isn't it? And they are not always well suited to a context. For example, you put password in your system, right? It logs you in and you have the access now. It may also provide you the access to the network as well. That means it will be authenticating you there as well, right? But authentication is for physical security as well. Am I right? Not only the network based, the system based, but it's based for your physical security. So consider, let's say there are a very huge amount of employees and you ask them to enter their PIN while entering or accessing the building. So it will take too long, okay, and will create a disturbance in the workflow, right? Which is the lack of which CIA tried? It is creating the disturbance in the workflow. Exactly. It's a lack of availability, correct? Because a huge amount of employees over there. And like password or PIN over here would be in your lack of confidentiality, right? And then there are pretty good chances that people will simply open the door and hold it for other guys to enter directly. And that would be the lack of what? Yeah, you can say tailgating, but not actually tailgating over here. Lack of integrity. Perfect. So that would be a lack of integrity, right? So authentication design tries to anticipate these issues and implements a technology that fits these sort of a use cases over there. All right. So like what you can do, you can just let's say many factors are there. A very simple example I would say, like you put up a jobs on a like different timings, isn't it? So rather than putting up all those people on a single time, so that there will be a ruckus, you can say, a crowded disturbance, rather than make the shifts for these people. Okay. And like you can create other doors as well to make an entry into the office, into the building, and all these sort of things, right? So there are different techniques and different mitigation for that. But moreover, authentication design checks out for all these scenarios or for all these use cases, so that they can maintain your confidentiality, integrity, and availability, your CIA triad. All right. Now it brings us to your multi-factor authentication. So when we are talking about authentication, obviously it's a very common term, right? So multi-factor authentication. What do you understand by the term multi-factor authentication, guys? So an authentication technology is considered strong if it combines the use of more than one type of knowledge, or you can say ownership, and a biometric factor, right? Remember the knowledge, ownership, and biometric factor, right? Something you know is your knowledge factor, something you have is your ownership factor, and something you are is your biometric factor, isn't it? Yeah, so multi-factor verification, that's why it's a name, multi-factor authentication, right? So factors are your knowledge, ownership, and your biometric, correct? So combination of these factors is called as your multi-factor authentication, right? Or in short, it is also known as your MFA. Right, just write it for you guys. In short, it is known as your MFA, correct? So because single factor authentication can quite easily be compromised, right? A password could be, let's say, written down or shared to someone else. A smart card, if you are talking about a smart card, it could be lost or stolen, isn't it? And a biometric system could be like, could be subject to very high error rates, or you can spoof it. Am I right regarding a biometric? It's pretty much of a like spoofing can be done for your biometric ones. Right. But if you're talking about this iris scan, that's later on, we'll discuss about it as well. These rays are inserted in your eyes, and like they'll be checking all your retina and everything. So that's another type of story. But for now, we are talking about multi-factor authentication, and single factor authentication can easily be compromised. There are a lot of chances that a single factor authentication gets compromised, right? If you're talking about in terms of password, it's pretty much like a crackable, or if you're writing it down just to remember it, or like people they share with each other like in a friendly manner or so, right? There are different techniques, as I mentioned, like we have mentioned social engineering attacks, right? You make it like you become a likable person, and being a likable person, what you're trying to do, you are trying to take an advantage out of it. You make friends in the organization, and they'll be trusting you, and they will be easy giving the password over there, right? Or they will saying, okay, use my smart card, and all those bits, right? So you can connect. Good part is you can connect all these things. You can map it out, right? So different techniques are there to compromise a password, isn't it? A single factor, you can say, authentication method. So which brings us to strong, you can say, authentication, which requires like two or three types, right? If you talk about 2FA or your two-factor authentication, what will be on two-factor authentication? Yeah, you can say something and like which is like a pin, right? And something you have, or you can say any sort of a biometric, right? That's your two-factor authentication. Three-factor authentication combines all these three technologies, right? All these three factors. So this means that to authenticate, the user must possess the card, right? The user's fingerprints must match the template which is stored on the card, and the user must input a PIN or password over there. Correct? That's your 3FA. Perfect. Now, since we are talking about authentication, there are always authentication attributes as well. Let's show the next slide, which is authentication attributes. right? So if you have a look over here, what do you understand by the authentication attributes over here? Like if you talk about like somewhere you are, so it's a location based authentication measure, right? Some like statistics are about over there, like where you are, from which place you are accessing this network, right? So this could be a geographic location, as you mentioned, which is measured using a device's location service, or it could be by the IP address also, isn't it? Like geolocation via location devices or IP location, which will be identifying, okay, where does this particular system belongs to right now, right? So talking about this somewhere you are, so for example, if a user enters the correct credentials at the VPN gateway, right, but his or her IP address shows like him or her to be in a different country than expected, so access control might be applied to restrict the privileges which are being granted to that particular person, right, or that particular employee. So they will refuse that access completely. So that will be based out of your somewhere you are, checking the location of that particular person, right? Then which brings us to the next one, which is your something you exhibit. So what do you understand by the term something you exhibit? So something you exhibit refers to, like you can say, also refers to your behavioral based authentication and authorization over here. So with specific like if we talk about on your, if we emphasize this thing, it will be specifically emphasizing on your personality traits, right? For example, the way you use your smartphone application or your web search engine, right? It might conform to a like pattern or behavior that can be captured by machine learning, right? So machine learning, what it does, it analyzes your all those behavior, right? The way you search, the way you use your applications, the amount of time like you are opening one particular application in a day or so, right? So it will be analyzing all those things, correct? So it will be just making and learning all those patterns and makes a template out of it, right? So now let's say if someone else uses the device, their behavior will be different, which is pretty much obvious, isn't it? Let's say you are opening an application, or like you are using an application for say like 2 hours in a day or so. That's your max to max, right? That's an average. You can say like which you use an application over there. Let's say you are using an Instagram, so you use an Instagram like for 2 hours a day. So that would be, or that might be an average thing which might be in your pattern, which is analyzed by your machine learning, or the way you search. So might be, you know, the in the last session which we learned Google Docs. So might be you use Google Docs a lot, isn't it? And you use that way to search out for the things over the Google, correct? So this will be done what? They will be analyzing all these things over there, which will be done by your machine learning, right? So if obviously if someone else uses the device, their behavior will be different from yours, and that different pattern could be used to lock the device, right? Because obviously, like if someone else is using your device and their pattern is different, obviously as a secure mechanism, what you will do, you will be locking that device, right? And for that matter, they have to put up a re-authentication, and that other person won't re-authenticate because you know you are the one who can authenticate it, doesn't it? So that's a something you exhibit. All right. Then it brings you someone you know. Someone you know is like trusting thing over here, right? Web of, you can say a web of trust model over here. So where new users are vouched by the existing users, you can say. If you take an example, like to be very technical one, decentralized web of trust used by this your PGP, which is a pretty good privacy. It's one of the examples for that as well, right? Then we have guys local and network authentication. So what do you understand by local and network authentication over here? See, your knowledge based authentication using a password or any personal identification number, which is your PIN, right, is the default authentication provided, right, for most of the operating system out there, isn't it? Am I right? Like using a password and a PIN number, you authenticate yourself. That's the default method to authenticate in most of the operating system of ours. So knowledge based authentication relies on your cryptographic hashes actually. So a plain text password is not usually transmitted or stored in a credential database because of the risk of being compromised. Okay. So instead, the password is stored as a hash. All right. So whenever, let's say, as I mentioned, right, previously. So as I was saying previously, whenever you are putting up your passwords, right, in a database, right, for example, you register yourself or any of an, like if you're talking about an organization, you joined an organization, HR might be like, other team, IT team will be putting up a passwords for you, right? And they are maintaining all these things. So this is like table in your database. So rather than saving the passwords in a plain text format, right? Let's say 123 or ABC or anything over here. What it does, it stores those password in your hash format. Anyone out here like who is from database field or any from a web development field, you might have noticed, right? Moreover, when you write a code, you also mention like in which format you want to store the password in the database. You put up something like this, MD5 or so. Anyone who can vouch for it? So it's a hashing algorithm. So whenever you put up a code, right? So you mentioned over there, okay, whenever user is trying to register, okay, so if you register over here in the database, put up those plain text, calculate them into a hash format, and then save it into the database over there. Cool. So that's how you put up a password which is stored in your hash format. Now, when a user enters a password to login, an authenticator converts what is typed into a hash and pass that to an authority. Okay, the one who is responsible for it. So the authority will do what? It will compare the submitted hash to the one which is in your database and authenticate the subject only if they match. All right. So taking the example back over here. So let's see, you have given the username and password. So taking a password over here for now. So when you enter the password, for say you entered ABC only, okay, because we have written ABC over here. Cool. So what happens now? There will be an authenticator. What it will be doing? It will be converting, or you can say calculating this plain text ABC into an something in hash. Okay, you can say it's hash A over here. So it will be passed to your database. In database, it will be checking, okay, for this username, and it will be seeing since while doing this registration, all right, while doing the registration, you enter the password, and that password was stored in your database in a hash format. So let's say that hash was hash p. Okay, so now we are talking about a user A. Cool. So user A registered into a website, you can say, and while he was registering into the website, his password was saved into the database in a hash format. Okay, we are calling it as a hash b. Now what happened? Whenever he's trying to log into that particular website, so he'll be giving his password in a plain text format because he registered in a plain text format only, right? So his password, let's say, is ABC. So when he entered ABC in his password field, he hit enter or he hit the login button. All right, he hit the login button. As soon as he clicked the login button, this authenticator will be starting to convert this ABC into a hash. We are calling that hash equals to hash A. Now when it goes to your database, it will be cross-checking that whether hash A is equals to hash B or not. Okay, same algorithm will be used to calculate the hash. Okay, we don't know which algorithm they will be using. That depends company to company. So let's say they are using this MD5 per se. They'll be checking, okay, hash A, which is calculated by ABC, when you hit the login button. All right. If hash A is equals to your hash B, authenticate this person and let him sign in or let him give the access. Okay, just authenticate him because these hashes are matching, right? So that's how the things are being done. Amitash, no, we won't be discussing hashing. I'm just giving a quick brief idea regarding hashing over here. So this is like how these things work around, right? So Windows, talking about the Windows authentication, Windows local sign-in over there, right? Windows local sign-in. So you have this local security authority over there, right? You have this local security authority. What it does, like it compares the submitted credential to a hash stored in your. Now, anyone can tell me where does your like Windows locally store your passwords? And which database? SAM, exactly, guys. SAM1, right? SAM stands for Security Accounts Manager. So it will be checking those credentials to hash stored in your SAM database, right, which is a part of your registry. So this is also referred to as your interactive login, or you can say log on. Okay, and when you talk about Windows network signing, this LSA can pass the credentials for authentication to a network service. And the preferred system for your network authentication is based on Kerberos. So we won't be deep diving into it. Just we will give you a discuss of like few bits of it. Perfect. So then there's your Linux authentication, guys. You know, Linux local user account names are stored in your which place? Username, account names. It's your etc/password. All right. So when a user logs into a local interactive shell, the password is checked against a hash which is stored in which place? etc/shadow. So this is the process with your Linux one. Okay. Perfect. So many of you are having the sound knowledge of Linux as well. Good one. Then there is a single sign on. Right. So what do you understand by the single sign on, guys? Great. So single sign on system allows the user to authenticate once to a local device and be authenticated to compatible application servers over there, right? Without having to enter credentials login, enter the credentials again. Okay. So over here, you don't have to enter the credentials again to access other applications I'm talking about. Okay. And for example, Google. So what happened? If you sign into Google, guys, you don't need to sign in then again into your YouTube account or say into your Google Docs file or into your any other Google services, doesn't it? So let's say you have registered or you have logged in into a device and you have, let's say, if you're talking about a mobile only, right? So the very first time what you do, you log in into a mobile and it asks you for login with a Google account, doesn't it? So you log in with a Google account over there. And since you have logged in with a Google account, now you don't have to sign in into your YouTube account or let's say this Google Photos or these clouds, Google Drives, isn't it? Or the Google Docs file. You don't have to log in again and again on these applications which are supported by your Google. So they allow to just once you're signed into Google one, it will allow you to go and access the rest of the applications which are held by the Google, right? So when we talk about in Windows, guys, SSO is provided by your Kerberos framework, okay? Right? Kerberos. So what's a Kerberos? So we are not going in much details regarding the process and everything because yeah, there's like ticket granting service, TGTs over there, or servers over here, right? So moreover, in short, authentication, as you mentioned, using like giving the system a ticket, right? Using a system of tickets, or you can say ticket-based authentication over here. So since we are talking about Kerberos, just for your understanding, what is Kerberos? So according to your Greek mythology, guys, Kerberos, or it was also known as a Cerberus, was a gigantic three-headed dog that guards the gates of the underworld to prevent the dead from leaving. Okay, that was from the Greek mythology. So when it comes to computer science, Kerberos is a network authentication protocol and is currently the default authentication technology used by Microsoft to authenticate users to services within a local area network, right? So Kerberos, it uses your like symmetric keys cryptography and requires your trusted third-party authentication, right? All these services to verify your user identities. So they use the name of Kerberos for their computer network authentication protocol as a three head of the Kerberos represent a client over here. Sorry, I was looking at the message. Perfect. So when we like they use the name of Kerberos for their computer network authentication protocol. So as the three heads of the Kerberos, they represent a client, a server, and a key distribution center. Okay, a client, not A1, asymmetric, symmetric. All right. So I was saying the three heads of this Kerberos, three-headed dog. Each head represents something. Let's say this is one is client. Okay, this one is representing the server. All right, and the over here it is representing your KDC, which is your key distribution center. All right, that's whole of a cryptography concept you are asking about. But you can say symmetric, there's just one public key going around the network. When we talk about asymmetric, they are like two keys, private and public. So symmetric is pretty much of a fast one. Asymmetric is not that fast. You can differentiate in this way. All right. So that was a bit regarding your Kerberos. The whole process is different, right? When we talk about the course, we go for the certification purpose. That's another type of a story. But you should know regarding Kerberos, it might be very helpful when you go out for the interviews and all these purposes. So it will be very helpful and it will give a very good impression, I would say, if you are knowledge regarding the Kerberos. All right. So next thing is which we'll be talking about when we are talking about this authentication and all these passwords and everything, guys. Right. So we always talk about brute force and dictionary based attack. Anyone who can tell me what is a brute force and dictionary based attack? So what you do over here, you exploit weak user password selection, or you can say a weak cryptography mechanism over here, isn't it? So when we talk about a brute force attack, because you're trying to crack out a password over here, isn't it? You're trying to crack out a password and you're trying to gain the access out of it. Yeah. So if we talk about brute force attack involves repeated login attempts using every possible letter or a number and a character combination to guess a password. Okay, so an attacker, or you can say any malicious actor, is using brute force, like is typically trying to guess one of these three things: a user or an administrator password, okay, or a password hash key, or an encryption key over here. So either of these things is trying to figure it out. He's trying to attack a brute force on these three things, on either of these things. Okay, a user or an administrator password, a password hash key, or an encryption. Okay, so if you talk about brute forcing attack, guys, guessing a short password can be like relatively very simple and easy. Okay, but that case won't be with the longer password. So if you're putting a long password over here, brute force, or like if you're putting a long encryption keys, brute force can be like very like not so simple, I would say. It will take a lot of time. So the difficulty of brute force attacks grows like the longer the password, the difficulty for the brute force attack goes with that. Okay, because it takes a lot of time for going all those combinations and each and everything, isn't it? You're just trying all those combinations. So if you put up a long password over there, it will definitely take a lot of time and a lot of difficulty to do a brute force attack. Okay, so when you talk about a basic form of brute force attack, it's an like exhaustive key search, you can say, which is exactly what it sounds like, isn't it? Trying every single possible password solution, that is like lowercase letter, capital letters, numbers, and special characters out there, right? So it will go character by character until a solution is found. You know, that depends. Like 4, I would say very easy. Like if it's like 10, 12, yeah, take a lot of time. Right? All those combination will be put enough, and definitely it's gonna take a lot of time over there for that matter. Right? That's your brute force. So when you talk about dictionary tag over here, so in dictionary you use a dictionary to test like common words or phrases over here. Exactly, Arjun. So if you can see over the picture as well, it's saying trying apple, trying blueberry, trying Justin Bieber, trying any like it's trying to go with the like secret written into like different formats. So it's basically the common one which people do over there. Let me in, and so basically what happens? There's a dictionary out there. You're trying to put up the common words. You are trying common words over here. You are trying to crack the things out of that particular common words or common passwords. So you can say it's actually a dictionary, but it's more likely for them to contain a shorter list of words that an attacker thinks are likely to be successful over here. Okay, so it's commonly used for password lists with popular names, pet names, movie names, or any television character you can say, and other words can be part of this dictionary list. So if you talk about specifically, if you talk about in Linux, yeah, birth dates can be over there, perfect. So if we like country names can also be even there. So like normal genuine one, like people which they prefer to go with a common password over here, right? So they are like I would say wordless also. So if anyone having this knowledge regarding Linux one, they will be knowing, okay, there's pretty much good wordless in it, which goes by the name rockio.txt. Anyone heard about it? No? Okay, perfect. So rockio.txt, what it does, this is like, you can say, a very big file, guys, in your Linux-based machine, or if you specifically talk about Kali or any parent one. So it's pretty good one list. It's pretty big. It contains lot of these dictionary names, you can say, a common password. It could be around 1,000 or four, so even more than 1,000, right? Another part which we tell in further course, how to use the commands and like how to use all those keys and all those switches to put up these dictionary attacks over there into a machine or into any particular port and all those bits. Okay, so if you take just an example, you can always research out for this Hydra command is always there, right? Where you mention the username list and the password list to try to put up a brute force attack and all those bits. So many more are there. Just giving an example of a Hydra. Always you can go for it and you can Google as well. All right. Then there is hybrid. Hybrid is nothing. It's just a combination of your brute force and a dictionary based attack. All right. And if we talk about the rainbow table attack, anyone heard about it? Right. So if you guys can see, this is a rainbow table. I think many more are over there, but I'm just showing you one out of it. So you can see on the left hand side, we have these hashes over here. And on the right, we have plain text corresponding to it. Right. So if I take this hash, if I place it over here, I have taken a space, every space, even a space also counts. Okay. So if I submit over here, you can see it says status cracked, and it will be like giving the plain text which says OG. Correct. So this is like what happening. Okay, I will just do one thing as well. Change it. Let's say I'm putting a 1. If I do yes, it says not here in database, never tried. Okay, so you can figure it out from this thing, right? What is happening that over here, these guys or any person who is maintaining this particular website, he have put in a database and he has calculated few hashes. Okay, and he has mentioned all those hashes in his database. So if you're trying to put any hash at this one, so what he'll be doing, let's say you were trying to put, just telling you from the pen tester perspective or anyone. So if you're trying to do what you are, you figured out any, you cached any hash, okay, from somewhere, like you were trying to do the pen test, somehow you got a hand on your on a particular hash over here. Okay, so yeah, Vishal, I'm just explaining that thing only. They won't crack it, you can not reverse the hash. So as I was saying, they maintain a database over here. Okay, so if you put up a hash which you found somewhere in the server or network, so you put up a hash over here. This hash will be doing what? This hash will be cross-checked, or you can say compared with the database which is behind this particular website. Okay, the backend database. So if it matches over there, then only it will be giving you the plain text, else it won't give you the plain text. Else it will be showing you or showing you the status not cracked. They have maintained a database of themselves in the backend. If your hash matches their database, they will give you the plain text, else they will. That's how does the database get updated? That's the responsibility of the person who is in charge of this website, right? So he might be doing what? He might be figuring out or calculating more hashes, and he'll be updating his database regarding them. Okay, so I believe that might be an error from their end, or you can say uh, from the place they are fetching these data. Okay, so obviously in their database they have maintained this sort of a scenario. Okay, you can say a problem from the developer end or anyone who might have stored this. So since we are talking about the table, right, in the backend, what might be happening is they are maintaining this database table, right? Hashes are maintained in this particular column, and let's say plain text is maintained in this particular column. Okay, so hashes, let's say for very first one, as you pointed out, very sharp eyes, I would say, Amrita. So let's say this one we took it right. For second one, it was giving the correct answer to us. If we take this one, okay, this might be over here in this place, and it will be just taking out this corresponding plain text. So might be what happened when the developer is trying to fetch out these things from the table. He might have not fetched it completely, or like it might be a coding error, I would say, or from the front end person or anything. It can be any error from their end to which it is not being displayed over here. The question is like you copied the hash for the whole plain text, right? For the very first one, but it only cracked OG for us. You can see OG, but it is not displaying the rest of the thing, that bracket P6 IQ, whatever is left, right? But for second one, it gave us the proper answer till this point. So that's what I'm saying. Maybe the problem from the this developer part, all right? Not like a big issue that we have calculated something else, just that one. Cool. I hope this rainbow table is clear to everyone. Great. So mitigation we have already discussed, right? You cannot try if you're trying 3 times, just do what? Don't allow the person to attempt more than 3 times, right? You just put up a, you can say 30-second delay, more than that, and you can permanently block your device as well with that perspective, doesn't it? The timing features are also there. So in this respect to each and everything, you can just try to do these things, right? Okay. So the very next one is your smart card authentication, right? So what do you understand by the smart card authentication, guys? You might have seen this, right? So we are here talking about the authentication technologies at this point, right? Which can be used as something you have or ownership position factor, you can say, correct? So isn't it? Ownership factor is over here, right? You own this thing. So many organizations are deploying multi-factor authentication respect based on smart cards and your USB key fobs. All right. So smart card authentication means programming cryptographic information onto a card equipped with a secure processing chip. You can see over here, the chip is over here, right? So you program any of a sort of a cryptographic information onto this chip. So the chip stores the user's digital certificate for that matter and the private key associated with that certificate, okay, and a personal identification number is used to activate the card. So you put up a multi-factor authentication also over here. All right, that's a smart card authentication. The Kerberos-based smart card login is over there, right? As we have mentioned, card gets read, card source user's private key and certificates, right? And use of card is protected by a pin over here. All right. Then we have this basically two-step verification. It's nothing much, almost similar, you can say, right? Two-step verification or out-of-band mechanism, you can say. It generates a software token on a server, all right, and send it to a resource, assuming that it is safely controlled by the user. Okay, we are talking about any sort of a message or a phone call or any email. So this is two-step verification. So, or you can say out-of-band mechanism. What is happening over here? A token, it generates a software token on a server. Okay, whenever you're trying to log in or you're trying to put up this verification, it generates a token on the server, and your server send it to your resource. Resource can be your like phone device per se. Let's take an example of a phone device. It sends that token to your resource, assuming this thing that you are safely using and that device or that resource is controlled by you properly and it's safe and secure and it's with you only. Okay, that's why server is sending that to you. So they assume this factor that if you are trying to verify yourself, you are trying to authenticate. So since that server is sending that particular software token which is generated over the server, so they consider this thing that device or the resource is secure and safely controlled by the user, or by the user as in us, right? So it will be, this token can be transmitted to the device in number of ways, right? A short message service, which is the SMS, wasn't a phone call, a push notification, or even an email account, right? The code, if you talk about SMS, the code is sent as a text to the register code number, right? Phone call, the code is delivered as an automated voice call. You might have seen this bot might be calling you and then giving you a particular token number or so, or a code over there which you have to enter, doesn't it? A push notification is already there, or given on any authenticated app on the PC or smartphone, and then there is always an email, which might like while registering yourself, you might have mentioned your email ID over there, right? So that particular code is sent to your, yeah, you can say that. That code is sent to your email ID, right? So you can describe these mechanisms like two-factor authentication as well. All right, this is also defined as your two-factor authentication. Exactly, Ashish. Okay, great. Then there is one more, which is your, since we are talking about the technologies over here, there is your fingerprint recognition, right? So what happens over here? A fingerprint sensor, guys, is usually detect the unique pattern of, you can say, the ridges making up the pattern in your thumb or in your finger. Okay, so the technology is like also, you can say, non-intrusive, means it does not cause any disruption or any sort of annoyance, and it is very simple to use. Although if there is any sort of a moisture or a dirt in your fingers, it can prevent it from reading, right? So basically, moreover, in short, it identifies all those ridges and patterns over here of your finger, right? And through that, it just matches out and try to give you the access or authenticates you, right? Exactly. It depends how many points you have to match over here. Correct. So guys, the main problem with over here with fingerprint scanner is that it is possible to obtain a copy of user's fingerprint, right? And create a mold of it. That will be very helpful to fool the scanner, right? You might have seen in the movies as well, correct? Now, what might be the solution of it? So the concern of these are addressed by actually the vein matching scanner, right? Or any vascular biometrics. So what they do, they require a more complex scanner over here. Okay, and you can say an infrared light source and camera to create a template from the unique pattern of the blood vessels in a person's finger or a palm. Okay, so these are the things which can help you to mitigate these sort of a problem. Rest, as you mentioned, that's absolutely fine. Multi-factor authentication, that goes by hand in hand, right? That's why we put up a multi-factor authentication, so that if one is able to do these sort of stuff, you won't be able to authenticate from rest of the path, right? That's your fingerprint scanner. Then guys, we have one more, which is your facial recognition. So when you might have seen this a lot of in your phones and everywhere, right? So facial recognition records, multiple indicators about the size and shape of the face. Am I right? Like the distance between each eye or the width and length of the nose, correct? So the initial pattern must be recorded under proper lighting condition. Okay. So with the very first one, let's say you are putting up a facial recognition, you are using your phone or any machine to record it, right? So it should be in your proper lighting condition. Okay. Not a dark place, so that it can read properly. Actually, if you put up a proper lighting condition, it will be reading all those facial characteristics very properly. Okay. And depends on the technology also. Okay, this can be a bit of a lengthy process, you can say. But similarly for this, facial recognition suffers from relatively high false acceptance, as we have also seen, like past year or even now, like if we talk about other phones, right? You know a similar feature or similar characteristics, even the twins, they can crack it out, doesn't it? You just put up a phone in front of them, and the phone screen gets open, right? So you have seen this false acceptance rate is pretty much higher over here, or even the rejection rate as well, right? So these things can be very vulnerable to spoofing over here, right? Anyone can spoof these characteristics, and he is able to access the phone or any device for that matter who is using facial recognition. So if you talk about limitation of facial recognition, it can be overcome by scanning more detailed features of the eye, right? On the image, you can see it's trying to scan the eye over here, right? And more specifically, it's trying to go with the retinal scan. So an infrared light is shown into the eye to identify the pattern of blood vessels over here as well. So the arrangement of these blood vessels is highly complex and typically does not change from birth to death. Okay, that depends if you are like not suffering any sort of a disease regarding your eyes or any sort of a accident and all these bits, then it can be changed, but else it won't change your blood vessels and all these things in your retina. So you might have seen this thing over the movies as well, right? Like when you are trying to access very confidential area, they put up this infrared light trying to scan your eye, isn't it? You might have seen in the movies, it's pretty much common, right? So that's the working of it. It will be just checking out for the pattern of your blood vessels, yeah, retina. All right, let's bring us to the next one, which is a behavioral technologies. All right, so it's like something you do, voice recognition, signature recognition, or typing, right? So something you do refers to behavioral biometric pattern recognition, you can say also. So rather than scan some attribute of your body, a template is created by analyzing the behavior, such as typing, writing a signature, or even like walking or moving, right? So the variation in motion, pressure of the move of your body, right, are supposed to uniquely verify each individual over here. So there are plenty of more, but this is like taking a whole cover up of this particular module, which is regarding your implementation of authentication control. I guess each and everything was clear to you guys. So the next one is your guys implementing identity and management control. So what do you guys understand by implementing identity and management control? So over here, each network user and host device, guys, they must be identified with an account, right? So that you can basically control, right? You can control their access to your organization's applications, data, and services. So the process that support this requirement are referred to as identity and access management. In short, it's your IAM. So within IAM, authentication technologies ensure that only valid subjects like your users or devices can operate an account. All right. So IAM, what it does, it maintains and check the controls, technical controls that how subjects will be interacting with the objects. Subjects over here, in the sense I'm talking about subjects, they are your users or devices or any sort of a software process. Okay. Any or anything else that can request and be granted access to a resource. Okay, that's a subject. Anything that can request and be granted access to a resource. So when we are talking about a resource are your objects over here. Okay, these could be networks, servers, databases, files, and so on. Okay, subjects are your users, devices, or any of sort of software process, you can say. Objects are your resources, like your servers, networks, database, files, and so on, these things. All right. So a security process that provides identity, authentication, and authorization mechanisms for entities to work with organization assets. Okay. So your security process, all these things. So an IAM over here, okay, identity and access management system is usually described in terms of four main processes over here. You can see identification, authentication, authorization, and accounting. So identification, it's like creating an account or ID that uniquely, what it does, it represents the user or a device or a process on the network, isn't it? You guys have an identity over there in your organization, correct? Everyone has it. Yeah, identifiable user, correct. So you are creating an account or an ID over there that uniquely represents you guys or the user over there in the organization. Then authentication is what? It proving that the subject is who or what it claims to be when it attempts to access the resource, right? That's authentication for it. Then there is an authorization. Authorization is determining what rights subjects should have on each resource over here. Okay, determining what rights subjects should have on each resource, yes, and enforcing those rights. Level of privilege, yeah. And then there's your accounting or tracking authorized usage of a resource or use of right by a subject and alerting when unauthorized use is detected or attempted. Okay, right. The system tracks permission usage in a log over here, right? A log is a pretty much good example for the accounting. Correct. The user cannot prevent this auditing part. Okay, so what is happening? In identification, the system owner confirms the user's identity and creates an account to represent the user. Okay, let's say his SID is 101. Okay, he got a password as well. So authentication is the user authenticates by entering the credentials and comparing it to the hash credential as we discussed, isn't it? And even like this, we are talking about this identification, guys. This identification you can relate it with the username, right? In database, what happened? We put up this user ID. You can say a very unique ID is also maintained in your database, so you can relate it that way. So it will be checking your user ID and the password. In it goes to the database, and the database will be checking. Okay, this 101 ID, it's a unique number, right? So let's say any other person who is joining the organization, for say after this person I am joining the organization, I might be getting the SID of 102. So they'll be just distributing these unique IDs in this format. Okay. So what happens now in database? All these things are being maintained, and a unique ID in respect to its password. Okay. So whenever he's trying to enter the password, that will be as mentioned a credential and comparing to the hash credential which are being stored. Okay. So your password settings after this is changing the hash, and this hash is like compared to the hash which is already being stored over there. If it matches, you give the it authenticates you, right? You get the access. Then authorization, for each action the account performs a permission list. Performs a permission list is checked to allow or deny the action, isn't it? So there is an access control list which is being maintained, as you also mentioned. I mentioned the privilege word, and you will be just putting about this ACL control list. You will be okay saying what all rights we are giving to this particular person, what all privileges we are giving to this particular user over here. So let's say we are giving him the rights of write, or sorry, read, but not of the write. So if there is this file, okay, if he's trying to attempt to go with the right one, he's not allowed to do that. He won't get the option even or to do that. And if he's trying to read, he is able to read this file. And all these things are being audited, right? All these things are being logged, and you can just do the accounting with that. Okay, I hope these processes are clear. Okay, next is your identity management controls. Okay, so over here, identity management control, guys, it's the way, or say discipline of managing the access to enterprise resources to keep systems and data secure. Okay, so being a very important or a key component of your security architecture, it can help verify your users identities before granting them the right level of access to workplace systems. Okay, so for this, we go with cryptographic materials like your smart cards, tokens, and identity providers. Yeah, Tava. So smart card have your user certificate and a private key, which is we have discussed, right? Which is used to authenticate to different PCs and devices. Token are used like as because it is not good way to make sure users authenticate themselves again and again on each application, isn't it? So rather than what is done, its user authenticates himself or herself to an identity provider over there, which is IDP, in a single sign-on system, right? That's a single sign-on system, how it's works. So the user over there, he authenticates himself or herself to an identity provider. Okay, authenticates to an identity provider. Okay, yeah, in a single sign-on system, and then he gets a token, and he can use that token as a proof of authentication in different applications and gets the authorization on base of that token. All right, that's how your token works. So when we are talking about, guys, is identity provider, and identity provider is like a federation partner, you can say, that vouches for the identity of a user. Okay, your identity provider is a federation partner that vouches for the identity of an user. So the IDP, or your identity provider, authenticates the user and provides an authentication token, that is like an information that verifies the authenticity of the user, right? Verifies the authenticity of the user to the service provider, right? That's how your IDP work, correct? So your IDP provider, it's either it directly authenticates the user, such as by like validating the username and passwords, or it indirectly authenticates the user, such as by validating and surely about the user's identity as presented by a separate identity provider. For example, like your Google does. is it? So if you are doing what, you might have seen this thing also, like when you're trying to register or when you're trying to sign in, right, into a Twitter account for say, or any of a other website, they give you an option over there that sign in with Google account, isn't it? You see these sort of options over there. Oh yeah, perfect. So these things are like giving like a federation partner given by your identity provider. So you can just, they trust this party, your Google one, and they let you sign in, right? So if you're taking the example of Google and Twitter, you can register into Twitter with the help of your Google account. All right. I hope this thing is clear. Let's put up a small task over here. All right. So guys, the task is you have to search for the lookalike domains. Okay. So regarding InfosecTrain.com. Okay. Try to find lookalike domains which is similar to your InfosecTrain.com. There might be a few bits of changes, but they are like lookalike for you. Okay. Like few bits of spelling changes would be there. So try to find out domain names which look alike like these, like this one, InfosecTrain.com, which you can use to fool around people. Okay, try to go for it. All right. So I'll be just showing you one. Okay, there can be many more. All right, but just to show you one among them. So we can see so that you can also explore it. There you go. All right. So what I did, I just put up a domain name on this search box and gave you a pretty good list regarding this particular domain name. Right, availables are over here, like these can be available, and founds are these many, right, 5 or 6. So what you can do, you can just like people can use these to like put up on a phishing attack or any sort of a social engineering attack to fool around the people and trying to take an advantage of that, right? So these links might be taking you to another domain, obviously, right? But these are the basis, like on this basis, you can just fool around people as well. Just to show another example as well, if I put up a name, let's say Tesla, yeah, Tesla.com, and I can see we are getting a pretty good list over here, like Tesla, Tesla, Teslas.com, Tesla, right? These ones. So what is happening actually? What is the main point out of it is people can use these links because we generally people do not check the URL on a regular basis, isn't it? We don't check URL and we don't go through them a lot. So even if you are talking about a techie person, they might be checking it. But if you talk about a non-techie person, the person who don't have much of a knowledge, they won't even bother about it. Mostly, even we techie person also don't bother a lot about these URLs. But being in a field of cybersecurity, you should be aware of the URLs as well, isn't it? So what people can do, they can just create or copy the original website, even like say few pages of it. Even if they were able to copy the or even they were able to make a look-alike of login page, they can do what? Take an advantage of it. They can put up the users to that particular website, and they will be putting up the credentials, and the actor or the malicious actor, what he'll be doing, he'll be taking the advantage out of it, isn't it? So these are the things which you should put up a focus on, or you should check before going and entering the website, right? So one thing, let's get back to the agenda. All right. So we have discussed regarding identity management controls, right? The next one is background check and onboarding policies. So I guess it's pretty clear. Everyone might be knowing it about these things, isn't it? So your IAM, your identity and access management, it involves both guys, your IT security procedures and your this human resource policies as well, right? So personal management policies are applied into the 3 phases actually. One is recruitment, or you can say hiring, isn't it? So locating and like selecting people to work in a particular job roles is a part of it here, right? So security issues here include screening candidate and performing background checks for them, right? So we'll talk about background check as well. Then we have one more, which one of the phases, which is your operational, or you say operation, which is your basically working, correct? It is often the HR department that manages the communication of policies and training to employees, isn't it? It is critical. It is very important that these HR managers, they set up programs that communicate the importance of security to employees. Okay, that falls under the phase of operation over here. Then there is your termination. Termination is like firing or retiring, you can say. So whether an employee leaves voluntarily, you can say, or involuntarily, termination is a difficult process. It requires numerous security implications over there, right? So we'll talk about as well when the person terminates, what all things to do over there, right? So talking about the background check, a background check determines that a person is who they say they are. So, who they say, we'll talk about it as well. Who they say they are and are not concealing any sort of a criminal activity in the past. So, or having any bankruptcy or any connection that would make them unsuitable or risky for the organization. So, employees working in high confidentiality and these sort of environments, or like with access to high value transaction, will obviously need to be subjected to a great degree of security or scrutiny over here, isn't it? So for some jobs, you can say, especially like federal jobs requiring a security clearance, these background checks are mandatory over here, correct? So some background checks are performed internally, whereas others are done by an external third party as well, isn't it? So even in your organization, you might have seen this, they put up a background check for you guys, correct? Then there is onboarding, guys. Onboarding at the HR level is the process of welcoming a new employee to the organization. As part of onboarding, the IT and HR function will like combine to create an account over there, isn't it? Like even like say that identity part, they create an account for the user to access the computer system. They assign the appropriate privileges, right, and ensure that the account credentials are known to the valid user only. Correct. So the task and processes involved in onboarding, they include, let's say this one, secure transmission of credential, correct? So once they create an account and give those credentials, the password, they have to determine and make sure these things that uh, the transmission of your credentials, right, it's secure, correct? So in the secure transmission of credential, you can say creating and sending an initial password or issuing a smart card securely. So this newly created accounts with simple or default passwords are an, we can say, vulnerability which can easily get exploitable, right? Then we have asset allocation as well in your onboarding process. Asset allocation, right? So they provide you computers or mobile devices for the user, or like, and or if they agree to bring their own devices, handsets, which we're talking like BYOD, which we're talking about when we're doing the mobile part, right? Then there are training policies as well. They schedule your appropriate security awareness and these role relevant training and certification program for the employees, correct? Then we have this NDA. NDA is non-disclosure agreement. What do you understand by NDA, guys? So the terms often this non-disclosure agreement, your NDA, like it might be incorporated with within the employee contract, or even could be a separate document also, right? So what happens in this, when an employer or contractor signs an NDA, they are assuring that they will not share confidential information with a third party, doesn't it? That's your NDA. That's why you signed it. Not share this confidential information with any of the party. That's a NDA, non-disclosure agreement, right? Then we have, guys, your this, which is personal policies for privilege management. Yeah, Chetan, exactly. When inside or leaving also. Then we have this personal policies for privilege management. It includes separation of duties, least privilege, job rotation, and mandatory vacation, doesn't it? So, separation of duties, the meaning or motive of this separation duty is that no individual person or any role or a group should be able to execute all parts of the transaction or the process, right? A simple example serves to clarify that this principle would be like something: a single person should not be a judge, a jury, and an execution, isn't it? One person cannot be all these three, correct? So these are your separation of duties. So it's like a fundamental element of your internal controls, and the idea of requiring more than one person to complete certain key duties to prevent any sort of a fraud and errors, right? That's why you put up a separation of duties over here. Then there's your least privilege. Least privileges means that a user is granted sufficient rights to perform his or her job and no more, right? This mitigates risk if the account should be compromised and fall under the control of a threat actor, correct? You just limit them and you just do not give them much of a power, you can say, or the rights or the privileges, correct? But talking about the least possible also can create problems, right? But it can be like on a temporary basis, you can say, to give them a bit more rights. Because sometimes what happen, even if that will be coming further in the point, let's say if you're giving the least privileges to a person, then like if he gets a sort of a work in which he needs a bit more privilege to any particular folder or file, what he need to do, like he will be asking the person who is authorized, right? He will be asking again and again, again and again. This will be resulting in what? It will be just resulting in disruption of the workflow, right? He'll be calling again and again to a person, or the person who's having high authority or who's having a bit more privilege than him. Yes, necessary privilege only, not more or less. Or you can do what? You can even provide some further temporary basis according to the project or that situation. And then you can take back those privileges again, right? You can just allow over the time, and then you can take those privileges back. So just not to disturb the whole workflow and not to like involve others as well. Perfect. Then there is your job rotation as well, right? So job rotation, rotation of duties means that no one person is permitted to remain in the same job for an extended period, correct? So for example, if you say managers may maybe move to different departments like on a periodical basis, time to time, or employees may perform more than one job role, like switching between throughout the year. So you would do what? You are rotating these things, right? So rotating individuals into and out of roles, right? If let's say if you're talking about a like firewall administrator or any access control specialist, this do what? It helps an organization to ensure that it is not tied too firmly to any one individual, right? They are not dependable only to one individual only, because that can be a risk, isn't it? So this job rotation also helps prevent, as I mentioned, you can say in other words, abuse of powers, right? You even more than that, you reduces the boredom. If you are putting an employee for the same work throughout the year, he can get bored as well, right? So to reduce the boredom, you put up a job rotation as well, and what it does, it enhances your employees' professional skills, correct? Then we have this mandatory vacation. Mandatory vacation, guys. Okay, so it means that employees are forced to take their vacation time during which someone else fulfills their duties, right? The typical mandatory vacation policy requires that employees take at least one vacation a year in a full like week increment, so that they are like away from work for at least like for 5 days, you can say, in a row. So what happens during this time? During that time, the corporate audit and security employees have time to investigate and discover any inconsistency or any sort of a fishiness, you can say, in employees' activity. So that's what happened when the company asked you to go for the mandatory vacation. Okay. So for those who don't know, just make a note out of it. So whenever company is asking you to go for the mandatory vacation, just think in the back of the head, they are doing this auditing process behind this. So for this matter, there is pretty much, if you guys have heard regarding this stamps, yeah, and there is one more, this Chanda Kocher for the Indians. So if you guys have heard about this Chanda Kocher, so there was this money laundry case She was accused of this one. So it involved around your I guess 1 crore or one eight. I don't know exact figures, something like this, crores of INRs, you can say. Okay. She gave this loan to Videocon group, and this Videocon group was run by her husband actually. Exactly, Vishal. So you can always look around this use case. It's pretty much interesting, right? So this happened when she was asked to go for the mandatory vacation. So that's what happened when you go for the mandatory vacation. All right. So next one is offboarding policies, right? Since viewers are also telling me about offboarding as well. So it's like an exit part, right? An exit interview or any offboarding is the process of ensuring that an employee leaves a company gracefully. Okay, so offboarding is also used when a project using like any contractor or any third parties ends, right? So in terms of security, there are several processes that must be completed, right? One is account management, another is company asset, another one is a person asset. So when you talk about account management, so what you do, you disable the user account and privileges, correct? So you ensure that any information assets created or managed by the employee, right, but which are owned by the company, okay, they are accessible and not logged or disabled by the employee after leaving this organization, right? So that's our account management. So, and then there's a company asset. Company asset like retrieving any mobile devices, keys, smart cards, your USB media, and so, right? So the employee will need to confirm, right? They don't have any sort of a copy also of these smart cards or any devices or all these company assets, right? They have to ensure that thing as well. And then this personal asset, they wipe employee owned devices of corporate data and application if it's having any. So the employee may have, or like may also be allowed to retain some information assets such as personal emails or contact information depending on the policies, right? So offboarding policy include these three things primarily, and they have to check out for these things before an employee leaves, right, in this offboarding process. So these are policies mentioned over there. Then we have guys security based group, right? So what you are doing, actually what happens is like normally if you check at this first scenario, right, you are having this access control list. Okay, let's say this is one of a file and these are three individuals. Okay, this is user 1, user 2 and user 3. Over here what is happening, this user got the rights of, let's say, read and write. Okay, this got just of the read and not the write, and this user also got the accessibility of read and not the write. So if you can see over here, normally these are the conditions, but let's say if the number of people are increased, this can be very tough to manage. Right? It makes it more complex if you are counting each and every person out of it. So rather than making it more complex and tough, we put up into your group based. Okay, so we provide these security on the group based process. So this will your access control list, and we divided these permission, these access permission into two groups. One will be having only just read, one will be having read and write. So let's say these two permissions have the permission or the access of only read, right? So we'll be just mentioning them into one this particular read section or read group, right? And this third person, he will be in your read and write group. So anyone who further joins will be attached to this particular group. So you can just, rather than maintaining and doing what, like checking everything and changing the permission and all those access controls on each and every individual, you will just apply them to your group now. So it will just sort out all those problems and all those complexities for you, right? So you create two groups and then you assign further individuals to that. So everything which you want to change the permission, everything around, you just play around with these particular groups rather than going with each and every individual, which can be like of a very time consuming, isn't it? All right, I hope this is clear. Like you divide these permission into security based groups, right? That's the same slide which I've explained further. Okay, so like these are the privileges we have uh, given into the group based. Then we have this administrative root accounts, right? So a default account, is one that is created by the operating system or any application when it is installed over there. So a default account has every permission available. In Windows, this account is called as administrator. All right. and Linux it is called your root. Okay, so this type of account is also referred to as your super user, you can say. Okay, these are having like most of the privileges. So when we talk about administrator and the root one, right, these two ones, they are like the person having most, the accounts having most privileges. You might have seen whenever you're trying to open a file or folder, it might ask you in the Windows these things like you need administrator purpose or permission and these sort of scenarios, correct? So in talking about in terms of this Linux part, there's this user known by the root user. So like most of the processes are not allowed or permit to a normal user, right? They are allowed to only root user, you can say, or the one who is having the most privileges. All right. So to get into a root user, okay, to get into your root user, you just have to write these things. In Linux, I'm talking about sudo su. Then it will be asking you the password, and you will just giving this thing, and it will be just turning out to your root user. And after that, you have the most of the privileges, and you can access each and everything which you want to do. All right. Then we have this, guys, which is your secure shell keys. So secure shell is a network communication protocol that enables two computers to communicate, right? So like talking about in an inherent feature, right, of SSH is that the communication between the two computers is encrypted, meaning that it is suitable for use of insecure network. So SSH is often used to log in and perform operations on remote computers, but it may also be used for transferring data, right? Isn't it? So we use a program on your computer, like let's say an SSH client, to connect to our service, which is of your server, and transfer the data from storage using either a graphical user interface or via command line also. So a host key pair identifies a SSH server. So the server, what it does, it reveals the public part when a client connects to it. So the client must use some means of determining the validity of this public key. So if it's accepted, okay, if accepted, the key pair is used to encrypt the network connection and start a session. So SSH keys have often not been managed very well, okay, leading to numerous security breaches actually. If you have heard about this Sony hack, this also includes these bits in it, okay. So SSH clients will typically support your this SCP, which is a secure copy, and as you mentioned, SFTP as well, SSH file transfer protocol for transferring data. That's your secure shell keys. All right. Then is your guys account attributes and access policies, right? So in this, if you talk about account attributes, a user account is like defined by a unique, SID, a security identifier, right? A name, it can be a name, or any sort of a credential. So each account is associated with a profile. The profile can be defined with custom identity attributes describing the user, such as their full name, email address, contact number, department, and so on, right? So the profile may support media also, such as your account picture. Then you have this access policies over here. So each account can be assigned permission over files and other network resources, right? So access policies determine things like, you can say, the right to log on a computer, right? Right to log in into a computer locally or via remote desktop, or you can just say install software, change the network configuration, and all these bits, right? So account attributes and access policies include these things in there, right? The next is your account password policy settings. What would be over here in account password policy setting, guys? So since you're mentioning these things, okay, perfect, length, complexity, characters combination, and all these things, right? So what you're doing, you're putting more, or strengthening the password over here, correct? So you have this system enforce account policies over here, which can help you to enforce these credential management principles by changing these passwords of the user. So if you talk about the password length, as you mentioned, right? So it enforces what? To use at least a minimum length of a password, let's say of 8 characters or 10 characters, which you might have encountered while registering yourself, right? Then there is a password complexity as well over here. In password complexity, what you do, you enforce password complexity rules, that it should be like, alphanumeric, uppercase, lowercase, length should be this of 8 characters, and all these mixtures of it, right? All your alphanumeric, non-alphanumeric characters and all these bits, correct? Then you have this password aging as well. Password aging like forces the user to select a new password after a set of number days, isn't it? Then this password reuse and history, it prevents the selection of a password that has been used already, correct? So what you do, the IT guys, what they do, they block the previous passwords which you might have applied so that you cannot reuse them again. Or it can be like they can do these things in basis of timings, you can say, like let's say they will making a history of last 15 passwords which you might have used, and they won't allow you to use them again, right? So after 15, like the older one gets removed from the back end, then you can use that one. Okay, so they might be like putting up a database in which they have mentioned all those last previous 15 passwords of yours. So whenever you're trying to put up a new password, you cannot use any of the last previous 15 ones. You have to go with the new one over there. So these are the passwords policy settings. All right, I hope that's clear to everyone. Then we have account restrictions. All right, so account restriction, as you know, you restrict the accounts on the basis of network location, correct? Which is, we cover that IP address and geolocation based, right? So you can just determine the location of the system, and if it's from somewhere which it does not like in policies which you have not allowed to take an access from this particular location, so you can just easily block it out. You can do it in respect to IP address and the geolocation part, correct? Then you have this time-based restriction, correct? So where you check these all login hours and login duration, correct? So you check an account and like you check the authorization of a person on the basis of login hours, correct? So you cannot just allow, like if you're saying okay, he is logged in for more than which is permitted, so it can be like you can just drop him off over there, right? So you can just check on the time-based restrictions are always put up in your account restriction. The network location, your time-based restrictions are always there. All right. So all these things like your duration, login hours, like the maximum amount of time an account like can be logged in into your network. So all these things are mentioned over there, and you can restrict them in the basis of these. All right. Perfect. Then we have this account audits as well. Accounting for all actions that have been performed by users. The change in like version control system depends on knowing when a file has been modified and by whom. So detecting these intrusions or attempt to intrusion, right? So here records of failure, like failure type events are being mentioned over here, correct? And that can be very useful, right? And even if there is a successful type event also, that will be revealing a lot of information to these auditing guys, right? Any sort of a unusual access pattern, so these auditing will be helping out over there. So accounting and auditing, they help to detect account misuse, you can say, use of file permissions to read and modify data, or any failed login or any resource access attempts. These sort of things are over there. So they will be monitoring all your privileges as well, and if anyone is trying to revoke their privileges, that's also get audit over here, correct? So all these things are being in your account audits. Then you have also account permission. Okay, so on the one hand, setting privileges that are too restrictive creates a large volume of support calls, right, which we were talking about previously, right? Giving the least one as well, like if you're giving very least amount of privileges, all these things can be come up over here. So as I was saying, it creates a large amount of support calls and reduces productivity, correct? And like if you're granting too many privileges, it can, like, to users, it can weaken the security of a system as well, right? And it increases the risk of things like malware infection and data breach. All right. So a user may be granted elevated privileges on a temporary basis, as we were talking about before. Okay. So when the time is over, when his the privileges are done, or whatever he wants to access, when it's done, you can just revoke it back, and you can just give him the privileges which are apt or which are the required ones, right? You can always put up onto the default settings which you have initially created for that particular user. That's your account permission over here, right? Then you have this usage audits, right? Usage auditing means configuring the security log to record any sort of a key indicator, and then reviewing the logs for any suspicious activity. Okay, so account login is over here, and management events, your any sort of a process creation is over here, right? And like if any sort of a file share is there, or if I was trying to change the audit policy, right, and changes to system security integrity, all these things are, and all these things fall under your usage audits. Okay, which means configuring the security log to record any key indicators or any sort of a suspicious activity over here. That's your usage auditing. All right, then we have this account lockout and disablement. So what do you understand by account lockout and disablement? So if account, what it does, like if it misuse of that account is detected or suspected, the account can be manually disabled by setting an account property. So this prevents the account from being used for login again, right? Account disable means that login is permanently prevented until an administrator manually re-enables the account, right? Yeah, Ganesh, perfect, guys. So an account lockout means that login is prevented for a period. This might be done manually if a policy violation is detected, but there are several scenarios for automatically also applying this lockout. Okay, this can be happen like if an incorrect account password is entered repeatedly, or like when you are using time based or location based restrictions also, correct? So location based restriction, if it's found out these location based restrictions, you can always lock it out that particular account, so that the person cannot access it again. All right, this was regarding your this IAM one, right? And the very next one is implementation of mobile solutions. All right, moreover, these things are maintained in your like lab files, IP tables, and these bits. Okay, so talking about, guys, mobile device deployment models, these are the few models. Bring your own device, corporate owned business only, corporate owned personally enabled, choose your own device, and virtual desktop infrastructure. Right, so what do you understand by bring your own device? So the mobile device which is owned by the employees over here, correct? That's your own device. So the mobile will have to meet actually whatever profile is required by the company in terms of operating system version and the functionality over here. And the employee will have to agree on the installation of corporate applications and to some level of auditing as well in it. So this model is usually the most popular actually with the employees, right? But you also find some sort of a difficulties in terms of security and network management, correct? So that's your bring your own device. The device is owned by the employee, but you have to install some sort of applications which are asked by the company for the auditing purpose and all those bits. Then we have this corporate owned business only. So COBO is the device. The device is a property of the company and may only be used for company business, right? Exactly as you guys have mentioned over here. Simple one. Then we have this corporate owned, personally enabled. What happens in this? So the device over here, it is chosen and supplied by the company, guys. Okay, and it remains its property only, but the employee may use it to access personal email or their social media accounts or any sort of a personal web browsing. Okay, but it remains the property of a company only. Okay, and all these things which he can like access, like they are put up in the policies, and he can work around with the policies only on the basis of policies, nothing beyond that. Then you have this choose your own device. What's your in your choose your own device? So all over what is happening over here, it's similar to your corporate owned, personally enabled, but over here you get a choice. So company what might be doing, they will be saying, okay, we are providing these phones, and you can choose among this list. Like they will be putting Samsung, you can say OnePlus or iPhone, Motorola, BlackBerry, and all those lists, or at any models for say, and you can just choose one of them, but company will be providing it, and it's owned by the company only. That's your CYOD. Okay, and virtual desktop infrastructure, it's defined as the like hosting of desktop environments on the central server, and you're doing what, you're accessing them like a virtual machines in the cloud. Perfect. Yeah, great. And the next one is your enterprise mobility management. What does it mean? So this EMM, your enterprise mobility management guide, is a class of management software which is designed to apply security policies to the use of mobile devices and applications in the enterprise, in the organization, right? So the challenge or like of identifying and managing attached devices is often referred to as visibility over here. So EMM software can be used to manage enterprise owned devices as well as your BYOD as well, which is your bring your own device. Correct? So there are two main functions of an EMM product suite. Okay, if you talk about EMM one is your mobile device management, which is like you do what, you set devices for authentication, like they are like feature use like camera, microphones, and all those connectivity, right? So even with this MDM, you can do what, you can just put up a remote vibes, and you can reset the device also. Okay, that's a MDM management. Those are the roles for them. Then there is your MEM, which is mobile application management. It sets policies for applications that can process corporate data, and what it does, it like prevent the data transfer to any personal application, right? So you set up a application into the phones, into the mobiles, okay, and these application or these what they will be helping out, they'll be helping out in preventing the data transfer to any other personal application or copying it to another application and all these bits. Okay, so one is your application base, one is your device management base. One is fully controlled by the device management, and one is controlled in respect to the applications. In device management, what you can do, you can just like you can like switch off the camera and microphones and all those connectivity to protect your data, and you can also do what, you can just remotely wipe out the whole device and each and every data inside it, right? And you can just reset it out as well. And application based, like you set up an application into the mobile, and that application will be controlling all the process of corporate data, and it will be helping out like not to transfer, or like you can say prevent the data transfer of the company to any other application in the mobile. Okay, that's your MAM. Cool. Then we have this mobile access control system. So over here, if a threat actor is able to gain access to a smartphone or any tablet, right, they can obtain a huge amount of information, isn't it? And the tools with which to launch further attacks also. So they can take an advantage of it completely. So quite apart from, you can say, confidential data files that might be stored on the device, it is highly likely that the user has like cached passwords for services or for the like such as emails or any remote access websites over there, right? That's your mobile access control system, right? And then there is always this your guys, you can say smartphone authentication over there, in which what you do in this only, your access control can be implemented by configuring a screen lock, right? That can only be bypassed using the correct password, PIN, or swipe patterns. You put all these access controls over there. You put up this configuration of a screen lock is maintained, and you put up you can say pins and patterns and swipe passwords. All those things are used to bypass these screen locks or these authentication. Correct. And there are also like if we talk about this in the screen lock, we have this screen lock policy as well, guys. You know, in screen lock policy, like if you're trying to put up a passcode, incorrect password or passcode for many times, you can say, right? So that device gets locked for a particular amount of period, let's say 10 seconds, 30 seconds, or 40 seconds. Correct. But if the user is trying again and again, you can just permanently lock it as well. All right. We have other policies as well in this, and when we are trying to talk about mobile security controls, right? So we have this remote wipe. I guess you guys know what is a remote wipe, right? So if your mobile gets stolen, okay, if your handset gets stolen, okay, it can be set out to the factory default, or it can be cleared of all those data. You can say a sanitization word for it. You clear all those data inside it. Okay, so what can trigger this thing? Remote wipe. You can just put up a settings over there, right? Like if any thief, right? He stole your phone, and he's obviously like your phone is gotten it got logged, right? And he's trying to open it. Correct. So if he's trying to open your phone, guys, and when he's trying to open it, he might have put in wrong attempts over there. Let's say you have put on a limitation of 2 or 3. If he did this, you might have put on a kill switch in your phone. So as soon as he tried 3 times or like more than that, what you do, you trigger that kill switch, and it will just remove each and every data from that particular mobile. All right, it clears all those storage in it. Okay, that what else people can do, like they can put up this full device encryption method as well. Like it will be just encrypting each and everything. You set up a keys also, not to like protect data from deleting it. You can just put up a key which will do what, which will not actually delete the data, but it will encrypt it. Okay, that's the same thing, just protecting your data from getting deleted. All right, retrieval, if you are able to get that mobile, obviously that thing will be stored somewhere around the cloud as well, right? Backup plan is always there. But in case like you report to the police and all those bits, you try to figure out, you put up a fire. If you're lucky enough to get your hands on those phones, pretty much good one, you can always retrieve the data from that particular phone, but you always keep a backup also, isn't it? Then there is one more, just few terminologies regarding this thing, routine and jailbreaking. So when we are talking about the routing, we are talking about with your respect to Android, right? And when we are talking about jailbreaking, we are talking about in respect to your iOS over here, correct? So guys, just always remember, whenever you're trying to root any device, what happens once you do it, it goes into this non-guarantee part, right? So there's no further guarantee of it. So even if your phone gets, like you purchase a phone and within a month you rooted it, so you lose all those warranties and guarantees of that particular phone. Basically warranty. We don't talk about the guarantee over here. So yeah, warranty gets void, you can say, exactly, remember, right? So warranty gets void, it's off. Like you cannot go to the customer care to and show them the bill and ask them to, you know, like remake it, something like that. No, they won't do that because the warranty gets void over here. That's the disadvantage of routing. And be very careful if you're trying to go with the routing and jailbreaking, because it's very of a delicate work, you can say, because if any of a mistake is done, phone or your mobile gets as good as a brick. All right, as good as a brick over here, which means now you can like use that mobile to throw it, or you can use that as a brick to create a wall, but it won't work as a normal device. All right, that's totally bricked one. It's totally dead and it won't be any further usable. All right, that's your routing and jailbreaking. So company, because with the routing and jailbreaking, you have this a lot of control over the mobile device, and you can put up any, so you can put up any sort of application, or you can use any way around with that mobile. So company, they do not allow the routing and jailbreaking devices, right? You can pass the malwares and all those activities you can do with it. All right, guys, that's it for the day. That was the last one. Thank you, everyone. Thank you for kind words.